All right, as if that last video wasn't cool enough, putting everything together, let's do one more, okay? This time, instead of looking at graphs, let's look at tables. Now, tables are going to be easy because most of you were very, very good at recognizing functions from tables, all right? So let's go ahead and work with the table and see if we can figure out what is the equation that would give us that table. Now, this is going to be cool. Not only will you be able to create a function from a graph, but you can be able to do it from actual data as well. So let's do it. Let's see what we can come up with. All right, now the first thing, just like with the graphs, the first thing you got to do is decide what type of function is this. Now, how do I use a table and find out what type of function it is? Yeah, you do the differences. So let's check the constant differences first. So we're going to go 2 minus 5, which is negative 3, 1 minus 2, which is negative 1, 2 minus 1, which is 1, and 5 minus 2, which is 3. Remember, it's always the second minus the first. So those aren't the same, so it's definitely not linear. Let's try the next one. Negative 1 minus negative 3. Now, I'm only going to do this once. That means negative 1 plus 3, which is 2. 1 minus negative 1 is 2. 3 minus 1 is also 2. There we go. So there is a constant second difference, which means that this is quadratic. Okay, so we know it's got to be related to the y equals x squared. Now, what is happening to that? Okay, well, let's see if we can figure it out by looking at the table. Well, if it were just the parent function, what would the values be? So I'm going to do a second table kind of off on the side here. If I were looking at the parent function, right, if I put a negative 2 in, negative 2 squared would be 4. Negative 1 squared would be 1. 0 squared would be 0. 1 squared would be 1. 2 squared would be 4. So this is what the parent function would look like. If you look at the parent function, and then you look at the data that's given to us, what do you see? Can you see that every time we're adding 1 to y? So I need to add 1 to the y variable. Okay, now if I want the graph to add 1 to the y's, that means it's going to shift up. If I want the graph, no! If I want the graph to shift up, what do I need to do? Well, I need to add 1 somewhere, right? I need to add 1, in fact, to the outside of the function. And so all I need to do is go y equals x squared plus 1. And that right there would shift my graph up 1 space. It would increase each of the y values by 1. Pretty easy, huh? Here, let's do another one. Let's do another one. All right, here we go. So let's check first. 4 minus 2 is 2. 2 minus 0 is 2. 0 minus 2 is negative 2. 2 minus 4 is negative 2. Okay, now we didn't look at absolute values before when we did tables, but I'm going to introduce you to it right now because this will be helpful when we actually look at what's happening to our graphs. Okay, to find out whether it's absolute value or not, you look, an absolute value, remember this is a graph for absolute value. It looks like this, right? So really what an absolute value graph looks like is you have a linear graph here, and you have a linear graph here, which means you're going to have two different linear graphs. Now, if it was a linear graph, what would we expect from the differences? We'd expect them to all be the same, right? Well, these two are the same, which means this relationship up here is linear. These two are the same, which means that the relationship there is linear. We also learned before that this is related to the slope. And I'm sorry, I did this backwards, didn't I? This should be 2 minus 4, which would be negative 2, 0 minus 2, which would be negative 2, 2 minus 0, which would be positive 2, and 4 minus 2, which would be positive 2. So this relates to the slope, which means the slope is negative, and this relates to the slope on the other side, which means the slope is positive on that side. So you can see that we got the negative linear slope and the positive linear slope, which means that this is an absolute value. So there we go. Let's look at y equals the absolute value of x. So let's do what we did before. If I were to just do this, the parent function, what would we get? Well, the absolute value of negative 2 is 2. Absolute value of negative 1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. And absolute value of 2 is 2. Now, this time, it's not going to be exactly the same. Remember last time I just had to add 1 to y each time. Well, I have to add 2 to get to y there, and add 1 to get to y there, and 0. So that's not quite working out exactly the way we wanted to, is it? So what we're going to have to do is we're going to have to decide how to best get from this y to that y. And hopefully that you can recognize that since adding doesn't work, maybe I can multiply, and that's what's going to happen. I just need to double each of these values. So I need to double the y value. So in order to double the y value, what needs to happen? I need to multiply by 2 somewhere. Am I going to put the 2 by the x? No, because that would change the horizontal values, wouldn't it? I want to put the 2 on the outside, because the 2 on the outside will stretch it vertically. It will increase the y values by a factor of 2. All right, let's do one last one since we got just a minute. All right, so here we go. Now you can probably look at this and already identify kind of what type of function it is, but let's go ahead and work through it. All right, so we've got negative 2 minus 4, which would be 2, negative 1 minus 2, which is 1, negative 0.5 minus 1, which is 1/2, and then negative 0.25 minus 0.5, which is 1/4. And then if I go through and I do this, it's going to be negative 1, negative 1/2, and negative 1/4. So obviously it's not linear, it's not quadratic, it's not absolute value because I don't have pieces that match up linear one way, linear the other. So my only other option hopefully is that it is some type of exponential, which means I need to do negative 2 divided by negative 4, which is negative 2 over negative 4, which is 1/2, 1 divided by 2, which is 1/2, 1/2 divided by 1, which is 1/2, and 0.25. Hopefully, if you don't know this, you can plug in your calculator, and you got 1/2 there. So we've got a constant ratio. Oh, schmeck. What in the world? Okay, so we got a constant ratio there. All right, so with the constant ratio, we now know that it's an exponential. So exponential is y equals 2 to the x. So now let's figure out what would happen if I put these numbers in. So let's go back and we'll say for the original parent function, well, I know that 2 squared is 4, 2 to the first power is 2, 2 to the 0 power is 1, 2 to the negative 1 power is 1/2, and then 2 to the negative 2 power would be 1/4. Okay, so let's look at these. What can we do? How can we turn this into that? All right, well, it looks like we have kind of some type of flipping occurring, right? Because it looks like the x's, the x to the negative 2 ends up with 4, whereas the original one was 2 to the 4th. Okay, so how can I flip all of these y's so that they go in the other direction? How can I flip those so that they're going the other way for the x values? Well, we can do that by, we can cause the y values to flip by changing the sign, right? By making it negative or positive. So, obviously I want the 2 to match up with the 4, which is up there. I want the 1 to match up with the 2, so that needs to be up there. 0 is where it's supposed to be. I want the negative 1 to match up with the 1/2. So what I need to do is the positive 2 needs to be in the position of the negative 2. The negative 2 needs to be down here. So I can do that by changing the sign. Now I can do that because I'm just going to rewrite it as y equals 2 to the negative x. And by doing that, that will cause a horizontal flip, right? All the negatives become positive, all the positives become negative. Now you may also notice, this makes it a little bit harder, that the values, it was positive 4 here and it's negative 4 here. So what needs to happen to the y values? Well, the y values also need to become negative. And so to finish it off, I'm just going to put a negative in front. Now, this one is a little bit harder because there are 2 things happening. You've got a horizontal flip and then a negative flip. So you probably won't see anything like that, but I did want you to see a situation where the flip occurred. The horizontal flip just means that you switch their places here, and then the vertical flip means that the positive y values become negative. All right, so hopefully that's enough to kind of give you a little bit of a head start. I'll answer questions and we'll do some work on this in class tomorrow. All right, so good luck and ciao.